Good morning, good afternoon, and good evening, wherever you are around the globe. Thank you to all the participants. Welcome to Elmarco's talk today about the Elmarco Incubator. Let me start by introducing my colleague, Katerina Rubackova. She's one of the customer support managers here at Elmarco. She's particularly focused on the university areas. She's worked on a lot of different projects with a lot of different customers, so it's really perfect to have her as part of the incubator.
Thank you. And on my right side, Tom Birchard, who is also experienced member of Elmarco for, 15 years, more with some breaks. Solution coordinator manager, and is part of the project built together. So we will be happy to answer questions afterwards.
Great, thank you. So we'll start it off just refreshing everyone on the mission of Elmarco, give you all the details about the incubator, and then finally finish up with the Q&A session. We really hope that Q&A section is actually the most valuable for everyone, because I'm sure that all of you have some more questions about the incubator. So again, we'll go through these things hopefully in 20 to 30 minutes, and then again at the end we'll have the Q&A session. The Elmarco mission is pretty straightforward. We design and manufacture nanofiber production equipment, and the goal of that is to help enable the use of nanofibers in future high volume applications. So from all of that, that's how we invented the incubator, came up with the idea for the Elmarco Incubator. It's really just a natural extension of our mission. We combine our know-how with our equipment to accelerate nanofiber product development, thus shortening the time to market in cooperation with our industrial partners, resulting in future high volume applications for nanofibers.
Okay, and what actually Elmarco Incubator is? So it is accelerator of your nanofiber idea by combination of two major groups. One of them is the equipment access, and the second one is the combination of know-how. So know-how of us, Elmarco, and know-how of you, potential participants of this project. But in any case, all that will necessarily need to lead to the commercial product. So at the end, the output of the whole incubator idea should be a commercial product. So how will the incubator support your idea? So as I already mentioned, you will have the full access to Elmarco equipment and access to nanospider technology. So briefly, I will repeat what the nanospider technology is. So we are spinning, we are using method of electrospinning, of course. We're not using any needles or nozzles. We are spinning from free liquid surface by depositing the liquid on the wire, which is the spinning electrode. So spinning is taking place between two electrodes, which are both wires. And the output of it is massive generation of fibers, which are ending up and covering the moving surface of the substrate. As you see on the video here, there is a short demonstration how the process looks like with one wire. When I mentioned the access to electrospinning equipment or the equipment at Elmarco, I mean the whole portfolio of the equipment that we're actually using at our facility, starting from the lab tools, going to half-meter lines, and but eventually, before the actual commercialization, of course, is necessary to provide the scale up on our large industrial technology. Excuse me, next slide. So basically, this is again summarizing the equipment which is available on Elmarco side, because we are daily working on a characterization of nanofibers and we're using many kinds of equipments to help us to do that. So I want to mention some of them, which is the scanning electron microscopy. Then we have a text test to characterize the pressure drop or pressure drop. Then we have the thickness measurement. We are providing porometry. and actually many others, depending what the application is. And now the combination of know-how. So of course, the Elmarco has a lot to offer because we are experts in electrospinning for more than 20 years. I think we, during that period, we work with many polymers. So you don't need to be electrospinning expert because that's us, the electrospinning expert. And we have a know-how in nanofibers in generally, so we know what the benefit of nanofiber is, where the role of nanofiber is in the particular product composition. And we are the equipment designers, so we are designing equipment the way that it's easy to operate, easy to provide the maintenance, easy to do the full scale up. Even the initial research is quite easy to work with the different polymers, solvents, and even the substrates. We have more than 30 patents globally. Our R&D center, it's also quite large. We are located in Liberec, actually in 2 locations. So it's quite nice to visit us. We have more than 85 employees, which we are kind of intermediate size company, and I said, with years of experience. So when I mentioned know-how, I meant not only know-how of Elmarco, but not more importantly, but the same importance is for the know-how of yours on the potential candidate, because of course we need a partner, we need you with the application expertise, and we also like to use your post-processing knowledge, which we obviously don't have because we are not bringing the final product into the market. We are just offering the tool to generate, let's say, the nanofibers. And you have the possibility, at least we hope you have a possibility of using different testing equipment so we can compare them and we can work together on the design of the final product.
So as Katka mentioned earlier on, creating a commercial product is really the ultimate goal of the incubator. It means that together with both of our know-hows, we have successfully taken your idea from that early stage all the way through to a final finished product. One of the great benefits of working with Elmarco is that we have global partners who all have our equipment that they operate for themselves. These partners are always seeking new ideas for new nanofiber products. The things that they're really interested in are the performance advantage that nanofibers bring, the size of the addressable market for that product, and then of course, the cost of the product or the price of the product relative to other materials that are in the market today. So I think one thing that's important to mention, sort of as at this point in the presentation, is the intellectual property. We want to make it clear that Elmarco, where we stand on this. All of the intellectual property around your idea belongs to you. So whatever you develop, that's all on you. Elmarco doesn't want to own that IP. But if there are changes to the Elmarco equipment that are necessary, now this doesn't happen very often, but it can happen, that would be something that Elmarco would want to own, because that's really our business. Our business is selling electrospinning equipment. As part of all of this, any participants in the incubator would have to sign a non-disclosure agreement. It's a very fair two-way agreement, and we don't think anyone should have any real issue with it. Another very important aspect to the incubator is what are the costs? What is it going to cost to participate? Well, of course, we want to do what is fair for the participant and for Elmarco. So just thinking about a couple different examples, if you're working for a university or a student at a university, the idea is that there will be no charge for the access to the Elmarco equipment. So that means, all of the equipment that Katka mentioned earlier on, that's our lab scale machines, our 0.5 meter wide, the 1 meter wide, and the 1.6 meter wide equipment, you would have access to all of that. We're also offering up to a 4-week travel stipend to come visit Elmarco. And that could be, you come for all 4 weeks all at once, or maybe it's 4 individual 1-week trips, or potentially it's no visits at all. It really just depends on the project and the project's needs. And speaking of the needs of the project, different projects will use different materials. If you're using the Elmarco standard polymers and solvents, then we wouldn't charge you for that. But if you have something special that you're using, some sort of novel polymer or some additives or something else that's not standard for us, then we would expect that you would provide that material while you're here at Elmarco. Now, on the other side, if you think about a startup, but a startup that's in the pre-revenue phase, not somebody that's out there in the market today, somebody early on, well, we would expect that them being a funded company, that they would potentially share up to 50% of the charges. And then also, again, the travel stipend would be just 2 weeks. In terms of the value that all of this provides, well, our normal rates for using the lab equipment is 1,300 euros per day and 2,200 euros per day for the industrial equipment. So what this means is if you have a project with Elmarco that's several months long, you can easily see that Elmarco is going to invest $20,000, $40,000, maybe even up to $100,000 of time using our equipment to your project. So really, the investment Elmarco is making is quite substantial.
So who should apply for the incubator? So basically, we welcome any idea or any candidate who bring the idea about the nanofiber product. As I mentioned before, it doesn't necessarily need to be the electrospinning expert because Elmarco is an expert, so we can definitely help you to set up the first trials, to think of the suitable polymers, suitable composition. So yeah, not necessarily need to be electrospinning expert. What we expect, though, you are expert in application, because that's where our weak point is, because we are working on different products only together with the partners. So we're not really bringing the product to the market. That's something what we expect from you and from your idea. And of course, the successful or the first potential candidate needs to have kind of driving force to commercialize the product in the end. So the part of the incubator on the incubator should be attractive for those of you who are really targeting for his or her product to be commercialized at the end. So how to apply? It's very easy. You will go to this link. This link you will find on our website, or later on we will send you this link in the follow-up newsletter. By this link, you will get to the form page where you fill in the questionnaire, and by that you will get to our database. We will quarterly evaluate these forums or the number of subscribers, and submission deadlines are visible on the screen right now. So the first deadline is end of March, second end of June, end of September, and end of December.
So as you go through the application process, the first step is that online web form that Kaka just mentioned. The idea of that form is really just to give us an early idea of your idea. Basically, you have to sort of convince us that it should be interesting and that it meets those criteria that we were talking about, especially in terms of commercialization. So it's really our vision that we would get 20 to 50 applicants in each of the quarterly rounds for the online submission. And then from there, we would narrow those down and pick somewhere between, say, 2 and 5 for each deadline. And then we would select those people for additional discussions. So that's where we review things like the timeline, the milestone, the product parameters, both have a technical and a business discussion around your idea to really figure out how does it move forward. And then from those 2 to 5, we would probably select somewhere between maybe 0 to 3 ideas. There's a possibility that maybe none of them are good to move forward. And then those people would then actually start as part of the incubator, and we would get going as soon as possible. So kind of the idea here is that, within a month of the online submission, we would get back to you and say whether you've been selected for the next step. That next step could take anywhere between 1 and 3 months. Again, it just kind of depends on the scope of the project. So really, we're kind of looking, you could be starting your project, your incubator project with Elmarco sometime in 2 to 5 months from the first submission. So I think it's really important to talk about, what are the selection criteria? What is really important for Elmarco as we look at these ideas and evaluate them? Well, certainly, number one is the performance benefit that nanofibers bring to your product. I think it's very obvious that if there's no reason to have the nanofibers or the benefit is very small, then it's not going to be something that's going to be suitable for the incubator. Certainly the need to scale up. So, our idea is that maybe today you're working with some small scale nanofibers, just a small little patch of them, and you need more material. So the idea is that someone who needs more material, that's actually more interesting to us, because then that usually then also means more market potential. So the need for more square meters of material is important to Elmarco.
Mhm.
So certainly, all of the things that come along with the incubator are not that unique to nanofibers or to Elmarco. There's a couple different steps that you'd have to take if you wanted to do this on your own. You could certainly buy and install Elmarco equipment, and then, through an R&D process, you could learn how to use the equipment, fine tune it, figure out exactly what knobs do what in terms of your end product, what it is that you need from the nanofibers. Once you get through all that, you would go through a scale up phase. And that's not only scaling up the nanofiber production, but that's also scaling up all the post processes and other things that need to happen to get it from, just being nanofibers all the way to that final product. And then finally, find some partners to help out with the actual production. But now if you do all these things with Elmarco, the idea is that we can do it much faster. And certainly one of the biggest places where we can speed things up is on that buy and install step. We have all of the equipment here at Elmarco ready to go today. So there's no need to do that step. And then certainly on all the remaining phases, again, Elmarco can speed things up. One of the biggest things is, because of all of our experience, in the past 20 years, we can really go faster with the R&D phase, because we know what things to do to affect the formation of the nanofibers. And then especially during the scale up is another place that we can really bring a lot of knowledge to. For instance, we had a client in the past that was working with a polymer and solvent that was really not compatible with the industrial equipment. Basically, they were using a solvent that was too volatile to be used at the larger scale. So they spent a lot of time developing and perfecting their recipe. It still worked on the machine. It made absolutely perfect nanofibers, but it wasn't something that could be scaled up very easily to the industrial scale. So when they finally came to us, then we had to do a lot of rework of things to get it to that point where it would work on the industrial equipment. Whereas if Elmarco is involved early on in that process, we can avoid all of that. We can avoid those sort of traps early on in the R&D phase and really help all of that move faster. And then again, because we have all of our industrial customers globally, we have a ready base of partners who are interested in new nanofiber products, and we can really help speed up the entire process there as well. So in the end, the main advantages of the Elmarco incubator are, we have all the equipment. It's installed, it's ready to go. You can come here tomorrow and we can make nanofibers for your product. We have over 20 years of knowledge, expertise, and experience working with not only nanofibers, our equipment, but then the end uses and end applications. We have a global base of industrial installations who are all interested in producing new nanofiber products. And maybe this is a good point to mention, if your aspiration is really to have a company of your own or a spin out from your university that's producing nanofiber materials, that's perfectly possible as well. You don't necessarily have to work with one of our industrial partners, but it's just a way that you could get to the market faster. And that's really, again, the whole goal of the Elmarco incubator, is to bring nanofiber products to the market faster than you could do it on your own. So with that, I would like to thank everyone for your attention. We'll now turn it over to the question and answer section. And I guess I'm told that there's a special Q&A section as part of the Zoom application. So you can just type in your questions there and we will answer them live here on the webinar. Thank you again.
But of course, if there are questions later on, you can always contact us
Via the email address you see here. Yes, please. Contact us at incubator@elmarco.com with any questions you have afterwards.
And before John comes to the Q&A question, maybe just one little remark. Actually, remind me that once we also had a customer who came with a kind of full developed recipe. That's what he told. And especially in the medical segment. But then we saw that maybe we could do something with it. We could optimize it to run it better, to be more productive. So we would recommend maybe to add a little bit of that, But because let's say the whole composition was already fixed by him, we couldn't actually do anything. So that's what I wanted to mention. If you come to us in an early stage where there is something to do, in order to get it more productive, get it more optimized, then please do that. Because later on it's maybe more difficult, even from the product development point of view.
So Mark, thank you. Thank you for your question about biopolymers. Certainly, there's quite a few of those that Elmarco has worked with. I know Katerina for sure, PLA, PLGA. Can you comment on any of the other ones?
I think I recall that we had one project with alginate, but I think it was always in combination with some other polymers, since the molecular weight is not that big. So we would combine it with one of the PVAs or polyethylene oxide. Actually, the same is valid for chitosan. We usually combine it with maybe other polymers that are also water soluble and pretty much good match working together. So that's experience. And polycaprolactone, a very nice spinnable polymer and very widely used, especially in the medical segment too. Similar question, right? With the PLA, PLGA, and others. Yes, the same experience. Yeah. We know how to spin them. We work with them, but really, it is not like daily polymer we work with, because obviously, I think it's because of the price, the cost of the initial polymer, and depending on the project frequencies that are coming to us. But please come with a proposal from your side, especially for those polymers, and we will definitely answer you.
So Annika, thank you for your question regarding scale up. In terms of how that process goes, really what we have found is that with our knowledge and with our expertise, if someone has a recipe that spins well on our lab scale machines, we are very confident that we can scale it up to the industrial equipment. Like I mentioned earlier, we did have that problem once where someone was using a solvent that was a little too volatile for the industrial equipment, but eventually we were able to find a solution by just changing that solvent system.
So other questions. Are the water-soluble polymer difficult to spin versus polymer in organic solvent? I wouldn't say so. I mean, it's kind of the same. The only difference I would see, which is more difficult with water-soluble polymers, is post-treatment. Because obviously, if something is soluble in water in the first place, it's going to be soluble in water also in the second phase once you turn the polymer into nanofibers. So nobody wants to have nanofibers dissolved in water again, or maybe in some portion, let's say. So this is something also to think about. It is the post-treatment process, especially with water-soluble polymers.
But even on the water-soluble, there are cross-linking agents that can be added that can help out with the durability once it's been electrospun, right?
Yes, correct.
Again, it's just the easy answer on all this is it depends. It depends on what your end application is. But usually, we have enough experience, we can find a solution to, things like that durability. So we have a next question is regarding the width of the equipment. So on our industrial scale machines, we have we have a 0.5 meter wide machine, a 1 meter wide, and a 1.6 meter wide machine. We've also done machines that are a little bit wider than that, but those are kind of special machines for different applications. So again, the standard widths are 0.5 meter, 1 meter, and 1.6 meter. And those are all multi-electrode machines.
There's an interesting question. This is more kind of really R&D question, how we produce carbon nanofibers from polyacrylonitrile. I believe we had quite some experience in the past where we actually had the furnace literally here at the Elmarco site, and we did some a test or with the thermal treatment to get actually the carbon nanofibers. We were successful, but I'm not able to tell you right now what is the procedure, but definitely we can answer you afterwards if you send us the email, because I'm sure that there are certain steps that needs to be taken. I mean, the time, temperature, and you need environment, you need to follow up it's quite sensitive, I would say. So, but I can definitely share details afterwards. Well, I can gather some information from the people from R&D.
I think this is a good point to mention too.
Yeah.
Here in Liberec, where Elmarco is headquartered, we have the Technical University of Liberec, and they actually have a lot of equipment on their own, and some of that equipment we can access, just like at many universities. So things like those furnaces, that's something that they could potentially provide. So again, if there is a piece of test equipment that Elmarco doesn't have immediately, there's a high likelihood that the university here may have it as well.
Yeah, because they work on all kinds of projects related to nanofibers, and then maybe
and
I believe
even not non-nanofiber projects.
Yeah. But I believe they may even have such a furnace, available. So that could be good to connect you with them.
So in terms of PTFE electrospinning, actually one of our colleagues worked on that in his previous life, and it can be done, but it's done in a emulsion solution. It's not actually, the polymer isn't actually dissolved in the solvent, but it's just there sort of as a particle, and it does actually work. In fact, it can actually be quite productive. But we haven't seen that's a really interesting application at this point. But now that's not to say that somebody might not come to us and say, hey, here's a really interesting application for using PTFE nanofibers. So again, we would welcome your application to the incubator.
What is it? Regarding solvent system, could you optimize it for industrial scale by using greener solvents? Well, that's actually a hot topic of today.
Very hot topic.
And then believe us, we'll be definitely working on that, because we're aware of that the toxic solvent, or particularly DMF, will be sooner forbidden. Banned to be used. So we are definitely working on that. And in some projects, we kind of already in a optimized stage. So yeah, please come to us also with that idea. We can definitely, well, I'm not able to share it right now what a green solvent it is, but we're definitely working on it.
And again, and it's going to depend on what the polymer is and what the end application is, as to whether or not there is a green solvent alternative for that end product. So
that's interesting.
Next question, just in terms of, if you just have a concept, can we help with developing the recipe? I think the answer is definitely yes. Back to the slide that we showed of, if you have the nanofiber idea and you have the end application expertise, then yes, let's put all that together and see if there's a project there. So we are really open to interesting things at any phase in the idea. So again, it could be like literally just very much an idea, all the way through to something that's ready to go from a small scale to a slightly more industrial scale, and then on up to the fully industrial.
Yeah, might be good to mention related to that. It's just the recipe is very general word. Recipe could be related directly to the solution itself. So, I mean, to selection of the right polymer, right solvent, but also to the substrate, because that's the combination. We are spinning on the substrate because this is the carrier basically, and also needs to match needs to have certain properties in order to be, successful in the electrospinning. So we also have expertise in that, because we work with many types of substrate during the years. So we can definitely recommend also something from that perspective. Next one. Do you want to answer that? What's that?
PEI, I don't know PEI. I hope you know PEI.
Exam began making the polymer solution. I don't know it either. PEI.
Sorry, we're not familiar with PEI, but if you send us an email afterwards, we definitely would be willing to discuss that with you. And then PHA, I don't know that one either.
PEP or PHA.
Same thing, I think. Neither one of us are familiar with it. That's not to say that Elmarco hasn't worked with it. We are definitely not the absolute brain trust in terms of the polymers. That would be our chemistry team, which we've got over,
maybe you mean HA, like hyaluronic acid or something, or is it, I don't know, in that combination, or sodium hyaluronate, then definitely we have some expertise in that. Maybe you can rewrite it.
Contact us later. We'd definitely be interested in talking with you more about it. So a very specific question on the next one, the better adhesion of the nanofibers for air filtration applications. Well, that's definitely a place that Elmarco has a lot of experience, and that's why we developed the adhesion module that goes along with our industrial equipment. So this is a machine that uses a kiss coating process to transfer some liquid adhesive to the substrate before it goes through the electrospinning chamber. And then after the electrospinning, that adhesive is dried off in the hot air dryer. Then the material is wound up just like normal. And what we have found in our experience is that the addition of that little bit of adhesive helps with the downstream processability of the material, basically creating a more durable nanofiber product. So thank you for your question.
Yeah, can the recipe created with your machines can produce only with your machines? That's a good question, but our machines are the best.
Well, okay. Now the truth comes out in the
no, but obviously we are representing company designing the machines that we are selling, and we're not selling only lab equipment, as you may notice. So we are selling really industrial, like a key solution of the whole technology. So I would say we are really trying, or our goal is to develop the recipes that is primarily running or our technology. But I know from the other hand that the recipes that has been developed, let's say with the nozzle or needle electrospinning system, it's also working on our system, maybe with slight optimization, slight modification, let's say, especially in terms of viscosity or conductivity. Those are very often the factors that are different from nozzle or needle. So from that perspective, you're taking it from the other end, like nozzle, needles, okay, these recipes can be transferred to our technology. I definitely believe that also the recipe developed for us, especially for buyers, can be used somewhere else, but primarily this is not our goal.
Well, and I think the important thing too is, when we talk about recipe, it's not only about the polymer and the solvent, it's about all the machine settings and all the process settings. So it's the temperature, the humidity, the voltage on the spinning electrode, the voltage on the collecting electrode, the distances between everything. I mean, there are, 50 or 100 different parameters that go along with the machine itself that Elmarco considers part of the recipe. The polymer and the solvent is really almost the easiest part of the recipe. It's all the other stuff that's really the most important. And it's all that other stuff that really helps take something from an idea into a truly industrial product.
And maybe it's also important to mention that, developing a recipe is one part. I mean, in terms of spinnability. So something is spinnable, okay, but we want that something is spinnable in a massive way. So, industrial way. So not just spinning in general, but we want to have it productive, as much as productive as possible. So that's why we are, tuning the recipe the way. And then, as Tom mentioned, not only recipe, but if you're asking about recipe, yeah, we can tune the recipe the way that is really the most productive. So that's what
Okay.
else we have?
Yeah. So then the next question, just on the parameters that contribute the most to nanofiber electrospinning. So certainly viscosity, concentration are very important. Those are very fundamental solution parameters. We have found that it's not necessarily temperature that's the big issue. It's more the humidity, and it's actually the specific humidity. And in fact, the humidity inside the electrospinning chamber is such an issue that Elmarco created our own precision air conditioning equipment to address that. So basically, when you purchase one of our pieces of equipment, then as part of that purchase, there's a large air conditioning system that helps treat the air and keep it at the proper humidity level for the electrospinning process. But I mean, there's a bunch of parameters that are very important. I mean, the voltage, the distances. I mean, it's hard to say any one or the other is the top, because it depends. Some polymers are, need things over in this area, other polymers need things over in this area. So it's very hard to just say there's just three things. I mean, it's really,
and actually all these need to lead, I mean, that's very important to mention, need to lead to the product specification, to the product properties you want, or those are, that are the target. So we can, of course, tune the product the way that by changing the concentration, we can change the fiber diameter, and we can change the filtration properties by that, or other properties which are related to nanofiber thickness. So, of course, those are important in terms of, let's say, optimizing the solution. Maybe I would mention liquid conductivity among the others. But all that you should take it as a kind of starting point for achieving your goal, which is the final product. Yeah,
exactly. All right, so the next question is just asking about core shell fibers. That is not an area that Elmarco has spent much time working on. We have seen some research papers of doing core shell with free surface electrospinning, but it's not something that is easily achievable with the free surface electrospinning process. So again, core shell, not really the strong point for the Elmarco equipment, but
although there are some articles in the literature saying
sure.
that there could be used some tricks, maybe with the highly volatile, solvent that you are evaporate and then the part remains, or some combination of solvents. So apparently people are trying to work in this direction, but it's not really common, let's say, task provided on our equipment.
And I think, one of the important things there is we haven't seen an application that can't be addressed with a standard nanofiber. That we haven't seen any place where it's, they have to have core shell to get X, Y, or Z. That can't be done some other way. And then the second part of the question was just in terms of typical fiber diameters. The Elmarco equipment can do fibers down to 80, even 50 nanometers, all the way up to 500, 600, 700.
Yes.
It just depends on the polymer. Certain polymers have a smaller range, others have a broader range. Others, tend towards the higher end. Others tend towards the lower end. It just really depends on the polymer and what the end application is.
And important is to realize that smaller diameter you have, of course, the lower throughput you're going to gain. I mean, in terms of, let's say, making the thick layers. Some people are, targeting for very thick nanofiber layer with very small fiber diameter. So, of course, you will achieve that goal in much longer time, let's say, than to have, kind of regular size of nanofibers instead. But again, I mean, depends on the final application. Of course, sometimes you need to have thin fibers for maybe better and more efficient filtration. So That's more a question on you to define what the product should do, and we will take off the part how to achieve the most optimized spinning, let's say.
Right.
Adhesion, we covered that or not? On metal surfaces are weak. Do you suggest anything about it? I wouldn't really 100% agree with that it's so hard, because I've seen spinning really on aluminum plates or some metal plates, and the adhesion was quite good. So it really depends on the composition, I would say. We are coming with another project that we will be spinning on some titanium surfaces. So I think everything is possible. Everything is possible.
Yeah, and that's
Yeah.
really one where we would definitely, encourage you to apply for the incubator. If you have an interesting idea and you think the issue that's holding you up is adhesion of the nanofiber layer to whatever substrate it is you're using, then let's talk about it. That, we're willing to address those types of challenges.
Yeah, adhesion is the sector by itself, right?
Yeah.
We are dealing with that, I mean, on a daily basis, not only with filtration products where it's already fully developed for this particular product, also by us, by our own method, let's say, but I'm sure there are other methods how to improve the adhesion or how to apply adhesion afterwards, like a post-treatment process. So not only before electrospinning or during the electrospinning, but maybe after that. So.
Okay, so another question about PAN and nanofibers and producing them into carbon nanofibers. At the moment, that's nothing that we have seen at the industrial scale, certainly as a continuous process. It's very easy to spin the nanofibers, the PAN nanofibers, and then take them to a secondary process for formation into carbon nanofibers. Again, this is another place where if we understand the need and that there's a clear market advantage or market need and a performance advantage, then would definitely be something that we would like to investigate as part of the incubator.
Definitely. I think we are at the end of the questions.
Yes, thank you everyone for all of your questions. We definitely appreciate your participation. If you have any additional questions, feel free to reach out to us via incubator@elmarco.com. One more question coming in.
Wow.
And again, please, if you have an idea, fill out the incubator application form. We definitely would like to discuss your idea even further. Ceramic nanofibers.
Inorganic.
Yes.
Our experience is to always use a combination of some ceramic nanofibers obviously come in a sort of precursor type in combination with some organic polymer, where afterwards, after the electrospinning, the organic part will be calcinated or burned out, let's say. So then the inorganic or ceramic part will remain. So that's, the procedure, how the ceramic nanofibers can be formed by our technology. And we definitely have experience with that, although it's not, recently often used because, again, maybe the potential is not that big or the market is not that big or great for that.
Yes, the email address is incubator@elmarco.com.
I think you will get more information when you look at our website later on, or definitely in the follow-up newsletter, which will be sent to you after this webinar or in coming days. Okay, thank you. Thank you very much again for listening us, and stay with us.
Yes, please be in touch.
Maybe mention next time, it's March 13, if I'm not mistaken. It's another Elmarco talk coming, and will be interesting topic with the industrial member, industrial speaker. So please follow us, and see you next time.
See you next time. Thank you, everyone.
Okay, bye-bye.